has the live started? Hi, hello everyone. Hi, Sharma ji, sorry for the 1 minute late. How are you? How are you all doing? Did you have breakfast? It's 11. How are you all? Hi, Sachin Sharma ji. Chai lover is here. Thank you. Hi, Beauty Yadav. How are you? How are you all doing? How is the preparation going? Only 10 days left today. Today is 7. On 17th, you have your boards. How is the Josh? Hi, Rohan. Hi, Sanika. How are you all? Okay, so in today's live, we are going to study in detail about the chapter Light and Human Eye. Okay, we will be doing numericals at the most with utmost priority. We will be doing the numericals and we will be looking at the concept as well. Okay. Who are you? Who am I? I am Aditi. I am here to teach you physics. Good morning. Arey, why are you scared? It's fine. See, these 10 days you are going to study. Just be calm. If you are scared, that means you are going good. You should be scared. But don't let it overpower you, okay? That's fine. It's fine to be scared. Hi, Ashar. I'm great, Ashar. How are you? Okay, so give me a thumbs up, everyone. Can we start this live now? We'll do the chapters Light as well as Human Eye. In the last live, we completed the chapter Electricity and Magnetic Effects of Electric Current. Okay? Everyone, mark your present. Give me a thumbs up that yes, ma'am, we can start the live. Let us start the live. Okay, let us start. Okay, we have thumbs up, roses and hearts today. Okay, let us start this live. Hi Veer Pratap, how are you? Okay, we are starting with the chapter this is our final revision now, right? And we will be starting that with the chapter Light, right? Great. Now the first thing we are going to see exactly today is, ma'am, what is light? Light is nothing but a form of energy which enables us to see this beautiful, this gorgeous world around us, right? Hi Piyush, how are you? How is your preparation going? Next, very important point, light has dual nature. What? Light has dual nature. What happened? Light was showing different kind of behaviors. So Isaac Newton said, okay, light is a particle, like electron, like proton. Light also has a particle which we call today as photon. Then after some time, Christian Huygens come and he was like, hey Newton, you are wrong. No, light is not a particle, light is a wave. So Christian Huygens suggested light is a wave. Why? Because of the phenomena like prism, like glass slab, and Newton suggested particle because of the phenomena like photoelectric effect, where you know those questions, right? Hi Ashar. You know those questions where the light strikes the solar cookers. In that case, we think that light is a particle. So what exactly it is? We deciphered that light is actually dual nature. It has both particle nature and wave nature. Hi Navdeep. Hello. Oh, Yadav ji is back. Okay, so until now, very basic, very clear. So light has particle nature as well as light has wave nature. Done. Next, we are going to see is reflection. Why we studied reflection? A very, very basic question. But do you know why do we study reflection? Navdeep, hi, good morning Navdeep, how are you? Do you know why actually do we study reflection? Hi Mikasa, Jeevan. Hello everyone, welcome to the live session. So what is happening? a light, these lights, I have lights all over around me. What is happening? These lights are hitting me and then changing its direction and going back into that camera and then into your eyes, right? So what is happening? Light is bouncing back. So the bouncing back of light when it strikes a surface is called reflection of light, right? कब से है? Live is started from 11 AM, Navdeep, and we'll cover 2 chapters, whole 2 chapters, light and human eye. Okay. Hi Divyanshu, welcome back. How are you? Where were you from all these days? Hi Shivam Kumar, how are you? So done. Why do we study reflection? Because light hits me and it bounces back. That bouncing back of light is called reflection, and we are going to solve the questions on laws of reflection and all other things, right? Ma'am, can you solve on this topic of first law of reflection? Incidents. Okay, let us study first law of reflection. Okay. So the first. Okay, Divyanshu, how was your practicals? I remember you said that you had practicals. Hi Anchal, how are you? Yes, Sharma ji, wait for a minute. Let us go through the concepts and we'll go to the questions, okay? We'll quickly go through the concepts, okay? Hi, good morning Shivam Kumar. Yes, take care. Wait for some minutes. We'll study about diffraction. What is diffraction? Okay. Laws of reflection, very important and very basic. They can directly ask you, first, angle of incidence is equal to the angle of reflection, very basic. And then the second, that, the incident ray, the normal, and the reflected ray, the incident ray, the normal at the point of incidence and the reflected ray all lie in the same plane. And when they ask you laws of reflection, you can draw this diagram as well. Everyone, there are some rules of this live. First, you have to have a pen and paper because we are going to solve a lot of numericals. Second, you have to answer everything. I'll ask you questions, you have to answer because that's how you study. Third, very important, in this live we are not here to just revise. We are here to see how to present the solution as well. Right? You have to know how to write the solutions as well. You have the knowledge, but presentation, my friend, is equally important. Okay. Are you Vimal? Thank you, Vimal. How are you? Okay. Yes. So this is the reflection. Next, we have spherical mirrors. What kind of mirrors we have? We have concave mirror, right? We have first is concave mirror and second is convex mirror, right? We have 2 kinds of mirror, concave mirror and convex mirror. Done. Next we have image formation by concave mirror. Who here wants me to explain in detail the ray diagrams of concave mirror? Let me know. Okay. Can I score 480 if I start now? Because I'm demotivated seeing my pre-board marks 410. Oh, you deleted that question, but it's fine. I didn't see your name, but it's fine. You can easily score good marks, right? If you are in your pre-board you are scoring 410, you will easily score more than 450, 480. Okay. Hi Aryan. What? Okay. Let's see these. We have 6 cases of concave mirror. We have 6 cases of concave mirror, right? The first case, the object is at infinity and the image is being made at focus. Second case, the object is beyond C. It is beyond C and the image is between C and F, right? Between C and F. Quickly go through these cases because we need it when we do the numericals. Okay? Yeah, Sharma ji, just give me 10 minutes, okay? Just 10 minutes for this chapter. Okay, then object at C, image again at C. Till then, you guys write me what is the nature of image that is formed in case of concave mirror. From 1st to 5 cases and then 6th cases. Write down the nature of image that is being formed in the case of concave mirror. Okay? Hi, Nikhil. Okay, next we have the object between C and F, image beyond C, the object at focus and the image at infinity or not formed. And the sixth very important case, the object between focus and pole, and the image will be behind the mirror and the image will be virtual, erect and enlarged, right? Done. Now, yes, real and inverted G1. In the first to 5 cases, we have image as real and inverted. Only one case is virtual and erect. Very good, Divyanshu. Okay. Next, we have image formation by convex mirror. In these, we only have 2 cases. Write down what is the nature of image formed by a convex mirror. Only one kind of nature of image is being formed by convex mirror. Write it down. Hi Prakash. Okay, so in the first case, the object is at any point between focus and infinity. Oops, not focus, between pole and infinity. Okay, so this is pole and here somewhere we have infinity. So the object is anywhere between focus and pole, infinity and pole. Object is anywhere between infinity and pole, and the image will be formed between focus and pole. Image will be between focus and pole, right? Done. Next we have, when the object is at infinity, image appears to be forming at the focus. Done. All the image part. The image formed will be virtual, diminished and erect. Very good, very good. Okay. Now we are heading towards our questions. Before that, very important point, what sign conventions for convex mirror? This is my convex mirror and in this, here we have focus. So focus of the focal length of the convex mirror is always positive. On the left hand side we have negative distances, right hand side we have positive distances. Left hand side of the pole negative, right hand side positive. U is always negative, right? U is always negative, and then the V is, in case of real and inverted it will be negative, in case of virtual and erect it will be positive, right? Then moving on to radius of curvature, since focal length is positive, radius of curvature will also be positive. Height we know, above the principal axis positive, below the principal axis negative. Done. Now for concave mirror, everything is same, only the one thing is different. See, U is always negative, V. In case of concave mirror, focus is on the left hand side, so focus is always negative and radius of curvature is again negative. And this is for same, real and inverted image we have negative, virtual and erect we have positive. Done. Sharmaji, this chapter has one of the highest weightage in your physics boards. They'll ask you case-based question from this chapter. They'll ask you MCQs, numericals, everything from this chapter. So this chapter is of very high weightage. Okay? Hi Sachin. Okay. Coming on to mirror formula. What is the mirror formula? Very simple. 1 by F equals to 1 by V plus 1 by U. Right? Very important. And magnification. Formula for magnification in case of mirror. Is what? Minus V by U. Make sure that you are putting a negative sign in front of the V. Right? Some of the parts, let's see. If your magnification is greater than 1, that means the image is magnified. If magnification less than 1, image is diminished. If magnification is positive, the image is virtual and erect. Magnification negative, the image is real and inverted. Magnification plus 1 or minus 1, we have same size, right? And magnification 0, we have point sized image that is formed on the focus. Okay? Okay. Let us move on to the questions now. The very first question is very basic, very conceptual. Do you guys know the answer of this question? Magnetic effects of electric current we actually covered in the last live. Okay, so you can go watch that if you want. In this today's live, we are going to see the chapter light as well as the chapter human eye and the colorful world. Okay, so let me know the answer of this question. Now in this question, why I got this question, very carefully read that. Define the following terms in context of diverging mirror. We have to define focus, but not for a converging mirror, but for a diverging mirror. We have to define what is principal focus and focal length. Very easy, but in the terms of diverging mirror. Principal axis is the imaginary line passing through the pole and the center of curvature. Yes, Anaya, but we've asked about principal focus, right? What is the principal focus of a diverging mirror? What is the principal focus of the diverging mirror? Let us see. For a principal focus, diverging mirror is my convex mirror. Is the point on the principal axis behind the mirror. So this is my diverging mirror. This is my diverging mirror, right? And we know that focus is behind the mirror. Focus is behind the mirror for the diverging mirror. Now, it is the point on the principal axis behind the mirror from which the reflected ray appears to diverge. This is very important. They don't converge at that point. They appear to diverge when a beam of light parallel to the principal axis strikes the mirror. Something like this happens, right? So, it is appearing to be diverging from the principal focus, right? Principal focus is positive. Yes, Divyanshu. Concave mirror is converging. Convex mirror is diverging. Focal length is also positive. Yes. The point where virtual and erect image is formed. Image is formed when object is at infinity. Yes, Sharma ji, you can write that. But this is the actual definition. This main word, these are the keywords. We have told you to highlight the keywords, underline the keywords, right? These are the main keywords. Appear to diverge, right? No, not just numericals. Numericals will come, but along with that, definitions will also come. Okay? Okay. Hi Mohit, how are you? Okay. Next we have focal length. Now again focal length of a diverging mirror, although this doesn't make any difference between converging and diverging, but still focal length of a diverging mirror. Whenever you are writing the answer, write it down of a diverging mirror. Is the distance between the pole and its principal focus. So this is my focal length. If you can mention that it is the point where image is formed, not just the virtual erect image. Yeah, for diverging mirror, virtual erect image is formed. You can mention that point. Okay? Okay. Hi Vrishti, Appu, Rudra, how are you guys? Okay. And here we come to the numericals. Now, one thing I want you to tell you, even if you have done these numericals again before, you must revise those again by writing, because in this we are going to see the presentation also on how to write in the examination, right? Okay. Yes, Mohit, what is your doubt? Okay, let us read the question. An object 4 centimeter in size. So height of an object 4 centimeter in size is placed at 25 centimeter in front of a concave mirror. So it is given, the mirror given as concave mirror. So one major rule we have for this live, for solving the numericals, we write as we read. Right? Easy question, Divyanshu is saying. Okay, solve it. Divyanshu, give me the answer. What is the exact answer of this question? Okay? Okay. Then an object is placed at 25 centimeter in front of it. So what is U? U is minus 25 centimeter, because object distance is always taken as negative. Okay? Then we have of focal length 15 centimeter. Again focal length is given as 15 centimeter, right? At what distance from the mirror should a screen be placed? At what distance from the mirror should a screen be placed? That means where will the image be formed? At screen, so we have to find the distance of image. In order to obtain a sharp image, find the nature and size of the image. So we have to find the nature and size of the image. Okay, okay, Sharma ji is saying minus 37.5 centimeter. Okay, okay, let us solve this. Okay, now we are clear that we have to find V. Why? Because we have to find the size. For size, we need to find the V first, then we'll find magnification. Let's see how we'll go about this question, right? Okay, so I technically have to find the height of image, right? And I have to see the nature of image. So for that, okay, nature of image I can also decipher from the magnification. So for height of image, I have height of object. So ma'am, I can directly use the formula height of image divided by height of object, right? But where is the magnification? Magnification is not given, right? So can I find magnification from minus V by U? Yes, you can. But where is V? Where is V? That we can find from mirror formula. Mirror formula 1 by V equals to 1 by F. 1 by F equals to 1 by V plus 1 by U. Understood, everyone? Okay. Next, we have to solve this question now. So, first we'll do by using mirror formula, we'll calculate V, right? So, mirror formula 1 by F equals to 1 by V plus 1 by U. So, 1 by F, focal length is given as 15 centimeter, but there is a we are given that the mirror is concave mirror. So, what is the sign of focal length? Focal length will be negative. Understood? Biology class will be there, Gokul, soon. Okay? Soon we'll do the biology class as well. Don't worry. Okay? So, 1 by F, that is minus 1 by 15 equals to 1 by V minus 1 by 25. Whoever gave me the answer, I guess Sharma ji gave me the answer. You have to solve it properly. Look at the presentation carefully, Sharma ji. Okay? Okay. So, we have to find V from here. This will be what? Minus 1 by 15 plus 1 by 25. So, you can take the LCM as 75 here. This will be minus 5 plus 3 and that will be 1 by V. So, 1 by V is equal to minus 2 by 75 and V will be equal to 75. Divide by 2 with a negative sign. So, 2 is 37.5. So, V comes out to be, image distance comes out to be minus 37.5 centimeter. Okay, anyone has any doubt? Okay, next we have to find the height of image, but for that we need magnification. So, can I find magnification using this formula? Okay, this is minus of minus 37.5 divided by, what is the value of U? U is 25. U is 25. So, I am guessing this goes on to 15. No, this goes where? How will you cut this? 375 divided by 250, everyone. You have to solve this in the exam. Someone gave me the answer as minus 37.5. What will be the answer of this? Let me know fast, fast. This is where we test your calculation, right? We test your calculation from here. Oh, namaskar, Arambhian. How are you, Arambhian? Rohan is saying minus 25. Okay. See, if you cut this, you will get around 1 15. Okay, when you cut this you'll get 15 and this cancels out, so magnification will come out to be 1.5. Magnification, oh, this is also negative, so magnification will be minus 1.5. Can you solve this calculation or not, everyone? Hi Yadav ji, how are you? Okay, any doubt till here? We had 15 and this 10 was here. Okay, see, I cut it with 25 and the 37.5 was here, right? So it comes out to be 1.5. Good. I'm great, Arambian. How is your preparation going? Till here, now we have to find the height of image. Now we have to find the height of image, right? We have the height of object. Height of object was 4 centimeter. We have magnification as 1.5. So can we easily find height of image now? Right? So magnification is height of image divided by height of object. Height of image is what? We have to find. So let us write HI, and height of object is 4 centimeter and magnification is 1.5. So this comes out to be height of image divided by 4 and height of image comes out to be 1.5 into 4. Right? That comes out to be 6 centimeter. Correct? Any doubt, anyone? Minus 6. Minus 6? Oh yes, I forgot the minus sign. Yes, very good, Sharma ji. Any doubt? Yes, 1.5 negative. Yes, Sharma ji. Thank you for that. Very good, very good. Any doubt? Now you know how to present this question? Ma'am, all good, but physics and chemistry has cooked me, struggling with basics. It's fine, Arambian. You just go through the concepts, okay? I have videos on this channel. You can go watch them. I have explained very in detail every concept, okay? You go watch them. If you have any doubt, come to me. You can come here and we'll solve the doubts if you have any, okay? And then we are solving the questions, so it will be a great practice for you. What did you not understand, Gokul? What did you not understand? Okay, done. Let us move on to the next we have. Okay, let me explain again. See, first understand what the question is saying and what they are asking. Okay, the question has given all such things, that height of object is given, object distance is given, focal length of concave mirror is given. Now they have asked us to find the nature and size of the image. How will we find the size of image? Now size of image is height of image, HI. Right? I can find it by using magnification. Okay, let us find using magnification. But I have height of object, height of image I have to find, but I don't have magnification. Okay, let us find magnification. How will I find magnification? With another formula, minus V by U. Now again, this is the case. U I have, V I don't have, magnification I don't have. So I have to find V first. How will I find V first? I'll find V using the mirror formula, because I am given with focal length as well as object distance, right? Yes, I have questions from refractive index as well. Don't worry, Sharma ji. Okay? Arambian, I have taken the live sessions where I have explained the whole physics in just 3 hours, I guess. So you can go watch that. If you don't want to go each chapter, I have the full live where you can go watch all the chapters of physics conceptually. Then come to watch the questions. Okay? Okay, done. Hi winner. So we started with mirror formula, we went about, we found the value of image distance, we find V, right? From there we found the magnification, that is 1.5, minus 1.5. Then we used again the another formula of magnification where we could find height of image. Done? Understood? हाइट ऑफ इमेज बाय हाइट ऑफ ऑब्जेक्ट भी कर सकते हैं. हाँ, yes. You can do that, Sharma ji. You can do that, but we have to see the nature of image as well. So if you'll have to find V. From there you can only, from magnification or from V, you can only find that nature of image, right? Done. But you have find magnification, but you have found from here minus 37.5. So yes, you have to use some of your brain. If you don't want to use your brain, this is the formula. Okay. Let's move on to the next question. A student wants to obtain an erect image. He wants to obtain an erect image of an object using concave mirror. So we are given with concave mirror, right? We are given with concave mirror, and the image he wants is erect image, right? Now the focal length, concave mirror of focal length 10 centimeter. So focal length of the concave mirror is 10 centimeter. First, everyone who's present here, tell me what is the sign of focal length. Thank you Gokul. Okay, right? What is the sign of focal length of a concave mirror? Then we have, what will be the distance of object from the mirror? What will be the distance of object from the mirror if he wants to obtain an erect image in case of concave mirror? Less than 10 centimeter and negative. Very good. Sharma ji, right? So we have concave mirror, right? We have concave mirror, and in first to 5 cases we know the image formed is real and inverted. Only in the 6th case the image is virtual and erect. Now we want erect image. So what is the case where the object is placed in 6th case? The object is placed between focus and pole. Between focus and pole. Since focal length is 10 centimeter, so the object distance will be less than 10 centimeter. Done everyone? Any doubt? Okay. 6th case, your love. Okay, Sharma ji. Okay. Lunch at 11:30, Rudra. Okay. Yes. Almost in each set you will get one case of 6th case, one question of 6th case, because it's like an exception, right? None? Okay. Let's go to the next question. A spherical mirror has a radius of curvature of 20 centimeter. We have radius of curvature as 20 centimeter, which is below in the diagram. Find its focal length. Let me know the answer to this question, everyone. This is very easy. And identify the type of mirror that always forms diminished, erect and virtual image. Which is the mirror that always forms diminished, virtual and erect image? Let me know fast. And state one use of this mirror as well. What is the use of this mirror? Okay. Hello ma'am, late ho gaya aaj. It's fine Prime. We have just started with the questions, right? Let me know the answer to this question. Till then, let me get the chart. What is the answer? What is the focal length? Okay, we have the answer as focal length 10 centimeter, radius is 2f, yes, and mirror is convex mirror. Okay, sine is also saying focal length 10, radius of curvature 2f. Okay. Tushar, hi Tushar. Okay. Divyanshu is in itself. Today he has come here to make friends. Hey Bhagavan. Mirror is concave. Okay, we have one person saying mirror is concave and the other person is showing mirror is convex. What is the mirror? Let us see which mirror is this. Okay, focal length is very easy. We know radius is equal to 2 times of focal length. If radius is 20 and focal length is 2f, so focal length will be 20 divided by 2, that will be 10 centimeter. So focal length will be 10 centimeter. Done. Identify the type of mirror that always forms diminished, erect and virtual image. Mind you, we have here a very important word, that is always. Always forms diminished, erect and virtual image. That is my convex mirror, friend. That is convex mirror. Concave mirror forms the virtual image, but it is enlarged, not diminished, right? And it is not always. Yes, it is used as convex. Yes, prime, you are correct. It is convex mirror and it is used as a rear view mirror. Very good. Yes, prime, I saw. Convex mirror. Okay. Very good. So the uses, it is used in rear view mirrors. It is used in rear view mirrors. Okay, let us move on to the next. We have a very important numerical. This is the kind of numerical. This is a PYQ. This has come in the examinations. So make sure you solve it properly, sitting down with pen and paper. Okay, a convex mirror. So initially they have told us that it is a convex mirror, right? A convex mirror used for rear view on an automobile has a focal length of 30 meters. Let me know what is the sign of focal length of a convex mirror. It is 30 meters. Okay. If a man is located at 60 meter from this mirror, use mirror formula to find the position of the image of the man as seen in the mirror. So a man is located at 60 meter and we have to find the location and nature of the image, position of the image. What is the sign of focal length and what will be the sign of U? Rear view mirrors. Yes. Is it PYQ? This is PYQ. Happy Rose Day, Anju. How are you? Okay. Positive, Sharma ji is saying. Focal length of a convex mirror. Positive. Okay, great. Okay. No, sorry, Divyanshu, it's fine. Just focus on studies as well. This is the most important time, right? This is the time where we don't have to distract. Positive, yes. And what will be the sign of U? U is always negative. Very good. Everyone is saying positive, so focal length is positive. But sign of U is always negative, right? Length is negative, ma'am. Length is negative. You don't write length is negative. U is negative. Okay? Length is negative, ma'am. Mirror is positive. Focal length, are you talking about? Okay, let us see. Siddhika is also saying positive. Very good. Okay, now we have to calculate. Keep in mind, for convex mirror, focal length is always positive and U is always negative for everything, right? So we will be using mirror formula here. They have written by using mirror formula. What is mirror formula? 1 by F equals to 1 by V plus 1 by U. F is given. F is plus 30 meter. F is plus 30 meters. Right? 1 by V, we have to find, plus U is minus 60 meters. Right? This is minus 60. So you can just solve this, right? Easy. Who here has a problem with calculation? Let me know. If you have any problem with the calculation, we'll take LCM as 60, right? So this will be 2 plus 1 equals to 1 by V. That will be 3 by 60 equals to 1 by V, and V will be 60 divided by 3, that is 20. So V will be 20 meters. Anyone here has any problem with calculation? This question will be of maximum 2 to 3 marks. It can be of 2 to 3 marks. If it comes in 5 marker question, then they'll give you some other A part, B part as well. Okay. Vishnu, very good, 20, but it is not centimeter. Okay. Keep in mind that it is a meter. It is in meters, right? Okay. Yes, 20 meters. Okay, let's move on to the next question. Next, we have a very, very tricky question, let's say. Okay, you have to be able to solve this, but use a little bit of brain. How do we do that? A plane mirror is inclined at horizontal at 60 degrees. We have a plane mirror. But it is aligned at horizontal at 60 degrees. A ray of light is incident on the mirror at an angle of incidence of 30 degrees. Angle which the reflected ray makes with horizontal. Angle which reflected ray makes with horizontal. Anyone knows the answer of this question or how to solve this question? This is a bit of a tricky question, so do not worry. We are solving this, but let me know if you know how to solve this question. Do you know how to solve this question? Okay, let us see. A plane mirror, we have a plane mirror. It is inclined to horizontal at 60 degrees. Now, see, this is always the horizontal. This is always horizontal, right? Correct. Now I have a plane mirror and it is inclined to horizontal at 60 degrees. It is inclined to horizontal at 60 degrees. So can I place my plane mirror like this? Right? Can I place my plane mirror like this? Correct. Now the angle is, this angle is 60 degrees. Correct. Now they are asking a ray of light is incident on the mirror. Mind you, this is the mirror, right? This is the mirror. Be very careful while doing these kind of questions, okay? This is the mirror. A ray of light is incident on the mirror at an angle of incidence equals to 30 degrees. So angle of incidence is equal to 30 degrees, right? Okay, now first we have to do while doing these kind of questions is to draw the normal on the plane mirror. First step, to draw the normal. So let us draw the normal from this point. Let me draw this normal like something like this, right? This is the normal to the plane mirror, correct? Now this is 90 degrees and this hole is also 90 degrees, correct? Now look at this very carefully. Sin 30 equals to 1 by 2, Sharma ji is saying. Okay, let us see. Let us see. Okay, so this is 60. Let me know that this is the opposite angle, vertically opposite angle. So this will be also 60, right? Now this hole is 90, this is 60. What will be this angle? This angle, this will be 90 minus 60, right? So this will be 30 degrees, correct? This will be 30 degrees. लाइव में कौन डरता है? अच्छा जी, यादव जी. Okay, now see, with the normal, this is my normal, this is normal, this is horizontal and this is my plane mirror, right? From the normal, if the angle of incidence is 30 degree, from the normal we take angle of incidence, right? So can I say that this will be the incident ray? This will be the red one. This red one, it will be the incident ray. The red one, it will be the incident ray. Any doubt till here? This red one, the dotted red one, it will be the incident ray, right? Now because this incident ray, why this incident ray is parallel to horizontal? Because it is making an angle of 30 degree with the normal, right? And that is what was required, correct? Now incidence ray is making an angle of 30 degrees with the normal. That is my angle of incidence. So the angle of reflection, will also be 30 degrees, something like this. This will be my reflected ray. This will be my reflected ray, and the angle reflected ray makes with the normal is also 30 degrees, because very important rule, angle of incidence is equal to angle of reflection, right? But we have to find the angle that incidence make, we have to find the reflected ray makes with horizontal. That means this one, this particular ray makes with this horizontal. This is horizontal. So what is this angle will be? This angle. What will be this angle? This pink one. The pink one we have to find. That reflected ray makes with horizontal. What is that angle? Think again. Sharma ji, Divyanshu, think again. Okay, let me know now. Now let me know what is the answer. Answer is not 30 degrees. We have to find the reflected ray angle that reflected ray makes with the horizontal. Okay? Angle which the reflected ray makes with the horizontal. 90, Vishnu Priya is saying. Correct? Okay, let us see. See, even if you can find this angle, or let us see if we find this angle. We'll see according to the options. So what these angles come out to be? This reflected makes with the horizontal one. This dotted one. This comes out to be what? 30 of this and 30 of this. This comes out to be 60 degrees. Right? First we have 60 degrees option. Second we have this 60 degree plus this whole 90 minus 30. Again 60 degrees. So 60 plus 60 is 120. Right? 60 plus 60 is 120. So we have two options. In these options, do we have 120? No. So the answer will be 60 degrees. Understood everyone? Not 90. How are you getting 90 prime? तुम सब पिट जाओगे. Okay, understood? 180 minus 120, 160. 180 if you are saying, okay, minus 120. How are you subtracting 120? It is correct, Rohan, but how? Where are you subtracting 120 from? Okay, option is right. See, I know why you are getting confused. See, this is the reflected ray, right? Now you have a question, ma'am, do we have to find that this angle or this angle? So you find both. This is 60 plus 60, right? That is 120, correct? But this is 30 plus 30. Right? That is 60 degrees. So in these, from these two, what is the option? Do we have 60 in the option or 120 in the option? We have 60 in the option. So just write that down. Done? Sarma ji, did you understand? You said 30 degrees, I remember. Okay? Yes, ma'am. हाँ मेरे ही बच्चे हैं, करेक्ट. Okay. Everyone understood? Yes, Arun Thakur, this is 60. Very good. The angle will be 60 degrees. Done? Let us move on. Okay, let us move on to the next question. Next we have, okay, we are moving on to the next topic, that is refraction of light. Okay, yes, I remember Sharma ji, of course. Okay, next is refraction of light. So what is it? Bending of light when it passes from one medium to the another having different densities. Those mediums should have different densities. Having different densities. Right? Very important point. Now, next we are going to study in refraction. We also have laws just like we had in reflection. Okay? What are the laws of refraction? The laws of refraction are, first is same. Now here the ray we have is not reflected. It is refracted. Right? Okay. Yes ma'am. Yes ma'am. Very good. Very good. Okay. The ray we have here is refracted. So, the incident ray, the refracted ray and normal to the point of incidence of two medias at the interface of two transparent medias at the point of incidence all lie in the same plane. Done? Okay. Next, second law of refraction. Basically, this is the law of refraction. Sin of I divided by sin of R equals to constant. The ratio of sine of angle of incidence, sine of angle of incidence to the ratio of sine of angle of refraction, sine of angle of refraction is a constant for the light of a given color for the given pair of media. Right? This is also called Snell's law of refraction. These laws are important. They can directly ask you in the examination. Okay? Right? Okay. Next we have, from moving here, we have this question. Okay, we have a question of refractive index. Everyone let me know. Before that, let me see. Wait. Okay. Let us study some refraction before that. What is the refractive index? Now I know when light goes from one medium to another, it bends towards the normal when it goes from rarer to denser, away from the normal when it goes from denser to rarer. Right? Now, what extent the light will bend will give you the refractive index of that medium. Right? The extent of change in direction of the ray of light that takes place in a given pair of media may be expressed in the terms of refractive index. Now, how do we write refractive index? Basically, refractive index is n to 1. That is refractive index of the medium 2 with respect to medium 1. That means the ray is going from medium 1 into the medium 2. Okay, now n21 is n2 divided by n1, right? And it is inversely proportional to velocity. So v1 divided by v2, right? Done? Everyone, look here, your boards are coming. You can do all the chatting you want. I don't have any problem with that, but there are students who are studying here as well. Okay, so make sure you are learning with it. Ng equals to C by Vg. Okay, Sarma ji, let me go to that question again. Okay, so V1 is the speed of light in medium 1, V2 is the speed of light in medium 2. Now let's go back to the first question we had. Light enters from air to glass. We have this air and we have this glass. Right? Light is entering from air into the glass. Now, of course, light is air is rarer and glass is denser. That is just common sense. Right? Yes, clear. Okay. Done. Now, The refractive index of glass is given as 1.5. Refractive index of glass. Light enters from air to glass. That means refractive index of glass with respect to air is given. This is refractive index of glass with respect to air. So this is 1.5, right? What is the speed of light in the glass? We have to find speed of light in the glass, and the speed of light in vacuum is given as such. That is 3 into 10 raised to power 8 meters per second. Anyone who can solve this question? Okay, yes, 1.5 equals to 3 into 10 raised to power 8 divided by Vg. Yes, very good. Sharma ji, I will remember. Okay, rarer medium to denser medium bend towards the normal when light enters from air to glass. Very good, Prakash. I remember your name, Prakash. Sona something, or am I wrong? Sorry if I'm wrong. Okay. Next, we have to solve this question. So let us solve this with a very basic formula, that is N21 equals to N2 divided by N1 equals to V1 divided by V2. Right? Now here N2 is what? Glass, and 1 is air. So we can write NGA. This will be NG divided by NA, and this will be velocity in air divided by velocity of light in glass. Correct? Now this is given as 1.5 equals to, what is the velocity of air? It is given as 3 into 10 raised to power 8 meters per second divided by velocity of light in glass, that we have to find, my friend. So velocity of light in glass will be 3 into 10 raised to power 8 meters per second divided by 1.5, which answer will be 2 into 10 raised to power 8 meters per second. Understood, everyone? Nm equals to speed of light in air divided by speed of light in medium. Yes, 2 into 10 raised to power 8. Rohan, very good. Okay, let me filter the comments. Sharma ji is saying 2 into 10 raised to power 8 meter per second. Very good, everyone. Very good. Whoever is giving the answers, I remember your names, and I am so proud of all of you. Ma'am, if there are 60 and 120 both, then what would be the correct answer? User. Okay, so they won't give you that option. And even if they do, they'll specifically ask you on what side they want you to answer. Like they'll probably ask you what is the angle, acute angle that reflected ray makes with the horizontal. So that means you have to tell the angle less than 90 degree, right? So they'll specifically mention, if they give the options both 60 and 120, they'll specifically mention what they want, okay? Or they'll give you grace marks, okay? Okay. What? Okay, let us see the next question, right? Next question, we have a little bit bigger question. Read it very carefully. This is the question where all your concepts of refractive index will be clear, okay? Dangerous question tha, okay, Sharma ji. But you solved it in this, like this, huh? How is it dangerous? Snowy. Oh, 10th ki class hai ye, ICSE. This is for ICSE and CBSE both. Okay, Snowy, Ayushi. How are you? Lokendra, he will get gussa. I'll give you the answer. She will be angry. ठीक है? अच्छा, उससे पहले वाला. Okay, शर्मा जी. Okay. She will be possessive, Lokendra. I am telling you, she will be possessive. Hi BG Gaming, how are you? Welcome back. Okay, 120-60 wala. Yes, that was a bit dangerous. Okay. Oh, thank you so much, Gokul. I scored 24 in physics because of you only. That means a lot. Thank you so much. And because of not me only, because of your efforts as well, okay? So I won't take the whole credit. Okay. Okay, ma'am, I scored. Yes. Okay. Yes, ICSE and CBSE are different, Yadavji, but I'm saying the concepts are mostly same, okay? I know ICSE has more concepts, has more topics as well, but this will help you in that, okay? Ma'am likes what? Ma'am likes what? Okay, on that, like the session. Everyone, like the session and complete this question. Okay, okay. 0.093, Rohan is saying. Okay. Okay, the refractive index of a medium X with respect to medium Y. We have a medium X and we have a medium Y. And we are given that refractive index of medium X, refractive index of medium X with respect to medium Y. This is how we write. Is given as 3.2. It's given as 3.2. And the refractive index of medium Y, refractive index of medium Y with respect to medium Z is given as 3.4. Right? This is the given. We have to find the refractive index of medium Z. What do we need to find? This is we need to find refractive index of medium Z with respect to X. With respect to medium X. Adya, like I'm sorry, I don't have that much knowledge about this, to be honest. Basic maths and standard maths. I'll get back to you. I'll I'll go find out and I'll get back to you, okay? Prime, batao. Okay. Ma'am, I don't study, but your video inspired me to watch you and study, okay? Thank you, Gokul. Okay, okay. Let's do this question. We have to find the refractive index of the medium Z with respect to the medium X. Now see, we have these, so we have to arrange these in such a way. Let us see what I'm talking about. See, NXY, that means refractive index of medium X with respect to refractive index of medium Y is equal to 3.2. This is given. Now, refractive index of medium Y with respect to Z. Y with respect to Z, that means NY divided by NZ is given, is equal to 3.4. Now, I have to find the refractive index of the medium Z with respect to X. Z with respect to X, that means N of Z divided by N of X. Right? So, N of Z, what do I have to do to find this? Right? What combination of this do I have to do to find this? So, let us say I multiply this. Let us say I multiply these two. If I multiply these two, what will I get? Nx divided by ny into ny divided by nz. Right? Now, ny and ny cancels out. Ny and nz, ny and ny cancels out. This comes out to be nx divided by nz. Right? Now, if I write these values, nx and ny is what? 3.2. It is 3.2 into 3.4. Right? Into 3.4. So, this cancels out. Nx by nz is left. And what is the multiplication of this? 32 into 34. This will be 128 into 6, 9. Right? This will be 8,81088. So, this will be 10.88. Correct? This is nx divided by nz. This is 10.88. But I have to find nz by nx. So, I'll just reverse this. I'll reverse this and that will be nz by nx. That will be 1 by 10.88. Right? Everyone. The refractive index of medium Z with respect to medium X is approximately 0.091. The speed of light in the medium will be, okay, yes. Okay, can you solve this? We have the answer as 0.09192. Right? So this is the refractive index of Z with respect to X, that is 0.09192. Done. Now we have to find the speed of light in medium X is 3 into 10 raised to power 8. So it is given, look carefully, it is given that speed of light in medium X is given as 3 into 10 raised to power 8 meter per second. Calculate the speed of light in medium Y. We have to calculate the speed of light in medium Y. So can I directly use NXY? Can I directly use NXY? We know that NXY will be equal to NX divided by NY. That will be equal to VY divided by VX. Done. Now NX divided by NY is given, that is 3.2. It is given as 3.2. Now V of X is 3 into 10 raised to power 8 meter per second. Vy we have to find. That is simple. 3 into 3.2 will be 9.6 into 10 raised to power 8 meters per second. Done, everyone? Yes, winner, what is your doubt? Although I think there is some mistake in this question because this is greater than the speed of light. 9.6 into 10 raised to power 8 is greater than the speed of light. What? Did I do any mistake? 3 into 10 raised to power 8, this is 3.2, NX by NY. This is correct, right? Technically this question is wrong, but they have given us, so we can solve it, okay? Winner, what is your doubt? Okay, let's move on to the next question. Next question we have is an assertion reason question. Now again, this question requires your conceptual knowledge. Okay, this question requires your conceptual knowledge. So let me know if you know the answer. Assertion: wavelength of light decreases when it travels from air to water. When it travels from air to water, wavelength of light decreases. Reason is wavelength of light in water is equal to wavelength of light in air divided by refractive index of water. Let me know if you know. Prime, you were doing the same thing 5 minutes back. Now you are asking me to block those guys. ये chat we don't know. Let me know. Just ignore those guys, it's fine. Let me know the answer to this question if any of you knows this. Okay? No, ma'am. Thank you, Google ji. Bio will have a little bit high weightage because bio has 5 chapters. R environment, right? So that is an easy chapter. You can just go through that on the 17th, right? On the 22. Let me know what is the, do you know the answer to this question? Everyone. What will be the answer of this question? Which type, Rohan? Yes, see, all the questions I have got you are either PYQs or sample question papers. So all of these are very important, okay? I didn't make these questions by myself. All of these are either PYQs or either sample question papers. Okay, Prime, don't worry. Let them. Okay. A, we have the answer as A. Adya is saying A. Prime is also saying A. Gokul is also saying A. I read your chat, Prime. I read. Okay. Appu is saying K. Snowy. Ayushi is also saying A. I remember. Okay. Let us see. All of you are correct, right? How do you know the answer to this question? You are very smart people. Can you give me the reason? Why did you say A? Do you know the reason? Okay. Okay. So, wavelength of light decreases when it travels from air to water. Now, listen very carefully. This is to clear your concepts, not just for this question, because this question will not repeat in your examination, right? Probably it will, but most chances are this is a PYQ, so it won't. So, what you have to do, you have to understand the concept clearly, right? Sabhi dangerous. Okay. So, you have understand the concept clearly. Now, remember N21 is equal to N2 divided by N1, right, everyone? Now, this is inversely proportional to velocity. So, this is V1 divided by V2, correct? Now, remember this very important thing. Velocity is directly proportional to wavelength. Velocity is directly proportional to wavelength. This is wavelength, lambda. This is wavelength. Correct? Velocity is directly proportional to wavelength. Now, is it easy? Remember this concept? This can be asked in the question paper. Okay, just prime, just wait. Now, N21 equals to N2 by N1 equals to V1 by V2. So, that means it will be lambda 1 by lambda 2, right? Now, wavelength of light decreases when it travels from air to water. Water has more refractive index, air has less refractive index, right? So, can I write N of water with respect to air? That will be N of water divided by N of air, and velocity of light in air divided by velocity of light in water. Wavelength of light in air divided by wavelength of light in water. Do you understand this whole formula? Okay, do you understand this whole formula? It's fine, prime. Okay, I have to teach all the students, right? You are one of the brightest one, I know, but this is the formula you need to remember. Okay, now N of water divided by N of air. That means refractive index of water with respect to refractive index of air will be wavelength of light in air divided by wavelength of light in water. So, what comes from here? We have to see wavelength of light in water. That means wavelength of light in water equals to wavelength of light in air divided by this refractive index of water with respect to air. Is it this similar to this wavelength of light in water? Wavelength of light in air divided by refractive index of water. Wavelength of water air divided by water. Then, understood this concept? I am from Punjab, winner. Everyone understood this concept? Right? This question on this concept can be asked in your exam. It is a very important concept, right? Okay, so everyone did get the right answer. Both A and R are correct. Now, wavelength of light is decreasing, right, when it travels from air to water. When it goes from air to water, this has more refractive index, so this will have low wavelength, right? Done? Punjab is a state. I am from Punjab. Okay, everyone done. Arey, don't say that, Sharma ji. You understood this question or not? Just remember this formula. N21 equals to N2 divided by N1 equals to V1 divided by V2 equals to lambda 1 divided by lambda 2. Right? And this also equals to sine of I divided by sine of R. Anyone has any doubt? Just remember this formula and you are done with all kinds of refraction questions. Okay? Okay. Let's move on to the next. We are done with refractive index. Next we have refraction from a glass slab. We all know it. It is very easy, right? The incident ray goes from air into the water. Ideally it should go straight like this, but it is bending towards the normal, that is in here, and because it is going from rarer to denser. Now it is going from denser to rarer, so it will bend away from the normal. So this is the exact path of the light ray. Now this is called incident ray, this is called emergent ray, this is called refracted ray. Okay? Oh, you are also from Punjab. Where in Punjab? Winner. Okay, so this is angle of incidence, this is angle of emergence. Now few things you have to remember in glass slab refraction. Yes, very good. I was going to say, Sharmaji, angle of incidence is always equal to angle of emergence. Angle of incidence is always equal to angle of emergence, and incident ray is parallel to emergent ray. Right? Some more things you can remember. Angle of incidence is always equal to is always greater than angle of refraction. Right? We know that because it is bending towards the normal, so angle of incidence will be greater than angle of refraction. Done? Okay. Hanji, you are from where, Prime? Okay. Let us move on to the next. Okay, one more thing. This, the perpendicular distance or the shortest distance between emergent ray and the extended incident ray. This perpendicular distance between emergent ray and extended incident ray is called lateral displacement. It's called D. It's called lateral displacement. Done. Next we have a question. Okay. Oh, nice question. Read it carefully, everyone. Read it carefully. Ma'am, I am only from ICSE or what? That I can't tell you. You have to ask everyone. Okay? Okay, Prime, you are from Delhi. I lived in Delhi for a few months. Okay. Right? Read the question very carefully. When light rays goes from one transparent medium into another transparent medium, it suffers a change in direction. We know that. Into second medium, yes. Which of these parameters, frequency, wavelength and velocity changes? Let me know. Though, yes, we had a meetup. Winner, we have to teach, right? So in here, right now I'm teaching, I won't be able to. After that I will. Okay? Done. Bubble Fakir, you are also from Punjab. Oh, lots of people from Punjab. You're also from Punjab. Where in Punjab? Ludhiana. Oh, nice. Okay. Anyone, everyone, let me know the answer to this question if you can. Which of these parameters, frequency, wavelength and velocity changes when light goes from one medium into another? Just a little Punjabi. PSL. Oh, Patiala, you're from Patiala. Nice. Sorry, my Punjabi accent slipped out. Noida. Okay, you're from Noida. Nice. Velocity and wavelength will change, and you're saying frequency won't change. Okay. All the three will change, user is saying. Okay. Hi, Pramod Kumar. Okay, let us see. Exactly, Sharmaji, you are correct. Velocity and wavelength will change. Frequency will not change. Why? Let us see. Now, do you remember this formula? Do you remember this formula? I told you this formula is your Ramban for your refraction topics. Why? Because see, when we go from one medium to another, refractive index changes and velocity changes, and similarly wavelength changes. So velocity and wavelength definitely changes. Velocity and wavelength definitely changes, right? But frequency, why doesn't frequency change? Why does frequency don't change? Because frequency depends on the source. Depends on the source of light. like I have a light of power 10 watt and another I have a light of 100 watt. So which light will give me more brightness, more intensity? That is the power with 100 watt. So that will depend on the frequency. Similar to intensity, the frequency depends on your source. Frequency means number of lights. Frequency means number of lights. I am from a small town near Bathinda. This is called Abohar. Done? So when the frequency depends on the source. Frequency is number of ray lights that are coming. So that depends on source. So it doesn't matter if it goes from one medium to another, source is same. So frequency will not change. Frequency will not change, but wavelength and velocity will change. Wavelength and velocity will change. Right? Okay, next we have a ray of light enters into glass from air. Does it bend towards normal or away from the normal? Let me know. Fast. This is very easy. Yes, Bubble Fakir, don't worry. I'll make you pass. Just attend the live sessions every day. I have uploaded all the chapters, and someone was asking, I guess Adya was asking, she can't go through all the chapters. There are 10-minute summary of all the chapters as well. So in 40 minutes you will be able to complete the whole physics, right? So you can go watch them as well. Okay. Oh, hi madam. Thank you, winner. That is sweet. I can read it. You are also studying very well. Okay. Thank you, winner. Okay. Towards the normal, Sharma ji is being very consistent. I admire you. Okay. Right? So it will bend towards the normal. Why? Because it's going into glass from air. So it is going from rarer to denser medium. So it will bend towards the normal. It will bend towards the normal. Great. Next we have light enters from air to glass having refractive index of 1.5. Oh, this is the same question we did, right? This is the same question we did. So everyone can do it. Let's move on to the next question. This is your homework. If you have to solve slide number 33. Write it in the comments or the chats. 33 slide answer. Okay, let's move on to the next. We have a question that I have to solve. You can't tell me, okay? Thank you, Fakir ji. Good morning, Satish Mishra. How are you? Okay. Away from the normal. No, user, it will bend towards the normal, right? It will bend towards the normal. Correct? What are those emojis, Prime? Okay, let's move on to the next. We have draw a ray diagram to show the path of ray light falling obliquely on one of the refractive rectangular glass slab surfaces. Mark the angle of emergence on it. Hi Akshu, how are you? Done. This is very easy. We all know how to draw rectangular glass slab. This is my glass slab, right? Make sure you are taking your scales with you. Make sure you are taking your scale and pencils with you. This is the incident light, right? Then you draw the normal at this point. You will draw the normal at this point. Then this ray will bend towards the normal. This ray will bend towards the normal. This ray will bend towards the normal. Something like this, right? And then again normal at this surface, on the second surface, right? And from here the ray will bend away from the normal, right? Angle of incidence, angle of refraction, angle of emergence. You make it like this, somewhere parallel to the emergence. something like this, right? And this is called lateral displacement. Done, everyone? Okay? Okay, now next we have image formation by convex lenses. Everybody know here? Everybody knows the image formation from where in Punjab? There is a small town named Abohar in Punjab. Winner. Why am I telling you my addresses? Okay. Okay, image formation by convex lens. First, the object is at infinity and the image is at focus on the other side of lenses. Here, the object distance will be negative, the image distance will be positive. Correct? For real and inverted images, the image distance will be positive in here. Okay? Done? Acha. Okay, Prime. I'll ask my team to make you the moderator. Okay? Next, we have beyond F2, beyond 2F1, sorry, beyond 2F1, the image will be between F2 and 2F2, right? Then at F2F1, the image will be at 2F2, right? Then the object between 2F1 and F1 and the image is beyond 2F2. Remember, all the focuses here are 2F2 and here F1, right? Next, on the focus, the image will be at infinity or not formed, and the image is between F1 and optical center. The image will be virtual, erect, enlarged, virtual, erect, large, sixth case, exceptional one, right? And the image will be large beyond 2F1. Done? Everyone? Any doubt? Any doubt in the image formation by convex mirror? Let me know. Fast. Okay, done? Then I am assuming live will be for another 2 hours, I guess. Done? Next we have image formation by concave lens. The object is at infinity. We just have two cases. At any point between infinity and optical center. So in here, the object is at infinity, the image will be at focus, but the image will also be negative and the object will also be negative. The image will be virtual, erect and diminished, right? And in here it is point sized, you can write diminished. In this case, the image is anywhere at any point between optical center and infinity. The image will also always be between optical center and F1. It will be virtual, erect, it will be diminished and on the same side of the object, right? Question, yes, Sharma ji, wait for 2 seconds. Done? Okay. Then we have lens formula. What is the lens formula? Tell me the magnification. Write down the formula of magnification until I write a lens formula. Lens formula is 1 by F equals to 1 by V minus 1 by U. Done? And magnification, my friend, it is in mirror. Magnification was minus V by U. In mirrors, finally khatam hua. Okay. In mirror, the magnification was minus V by U, but in here, the magnification will be plus V by U. Achha, Sharma ji, what subjects are you going to take in your +1 and +2, PU1, PU2? Yes, very good. Magnification is V by U. Refraction. Okay. Next, we have sign conventions for concave lens. See, all the things are same. Left hand side negative, right hand side positive. U is again negative here as well. But in case of image distance, virtual and erect. In this case, virtual and erect will be negative. Real and inverted will be positive. real and in this case we don't have real and inverted, but see, real and inverted will be positive, virtual and direct will be negative, correct? Then focal length of concave lens, concave mirror, concave lens, both has negative focal length, negative curvature, but convex lens as well as convex mirror both has positive focal length. 1 by f equals to 1 by v minus 1 by u. Very good, prime. Okay, science PCB, okay, that is great. So you will have refraction there, okay, but it's fine. No, don't be scared. I studied science and it's really pretty. Prime will also take PCB. You're going to prepare for MBBS, NEET or what with PCB? No, 11th is not dangerous. If you go into 11th, see, I don't know biology because I took math, but chemistry and science are really good. In 11th, physics is chemistry and science, chemistry and physics. Physics is just great. I love physics, so that's a different topic, but physics and chemistry are great. Physics, 4th, kar sakte. What does that mean? NEET, Prime, you are going to prepare for NEET. All the best. Okay. Next, let's see, we have the questions. A convex lens, NEET, ma'am. Yes, very good. Great choice. PCM, लाका नहीं, डॉक्टर जी. अच्छा, so a convex lens forms a real and inverted image of a needle at a distance of 50 centimeter from it. So we are given a convex lens. As we read the question, we write down what is given. Convex lens is given, forms a real and inverted image. Okay, we know that it is forming real and inverted image of a needle at a distance of 50 centimeters. So u is 50 centimeter and we know u is always negative. Where is the needle placed in front of the convex lens? If the image is equal to the size of object, they are saying height of image is equal to height of object. So where will the image, where is the needle placed in front of the inverted image? Okay, wait. A convex lens forms a real and inverted image of a needle at a distance of 50 centimeter. So this is u is not given, v is given. Be very careful, don't do mistakes like this. Now, how will I decide the sign of v? Object should be at 2f. Okay, Sharma ji. See, first, how do you have to write? How will I decide the sign of v? The sign of v will be decided because it is given that it is real and inverted image. Yes. It is given that it is real and inverted image, and we know that in convex lens, real and inverted image is also in positive side. For real and inverted image, in convex lens, real and inverted image has positive sign, right? That's why I give so much pressure on that slide, sign conventions, right? Done. So we will be positive 50 centimeter. Now if height of image is equal to height of object, also we have to find where is the needle placed. We need to find u in front of the convex lens. If image is equal to the size of object, also find the power of the lens. See, there are two parts here, right? We have to tell where the object will be placed. So first case is, I know that height of image is equal to height of object only in one case, that is when object is at 2f1. When object is at 2f1, image distance will be equal to object distance and height of image will be equal to height of object, right? Done. Now in the second case, you have to find the power of the lens. Now to find the power of the lens, you have to know the focal length, right? But we can also find that from here. See, if object is at 2f1 and the image then is also a 2f1. So this 50 centimeter is also 2f1. So 2f1 equals to 50 centimeter, right? Focal length is 50 divided by 2. That is 25 centimeter, right? Now we have focal length. So we can just find the power. But for power, you have to convert it into meters first. So that will be 0.25 meter. Power will be 1 by f. So power will be 1 by 0.25. That will be 4. So power will be 4 diopters. Everyone understood? 4 diopters, Sharma ji. Very good. Focal length 25. Very good, very good. Power will be 100 divided by focal length into centimeter or 1 by focal length into meters. Right. Great. Okay. Next, moving on to next, we have another numerical. A 2 centimeter tall object. What is given? Height of object, that is 2 centimeter, is placed perpendicular to the principal axis of a convex lens. We are given with the convex lens. Let me know what is the sign of focal length of convex lens, everyone. Okay, okay, that's nice, Prime. Great, great, good. Okay, okay, okay. Sharma ji is saying positive. Very good, very good. So for convex lens, focal length is always positive. Very good. Now focal length is 10 centimeter. Principal axis of a convex lens of focal length 10 centimeter. So focal length is positive 10 centimeter, right? The distance of object from the lens is 15 centimeter. Now distance is always negative, right? Then find the nature, position and size of the image. Also find its magnification. So we simply have to find V, right? We simply have to find V. Can we easily do that using lens formula? Let us find, we just have to find V, right? Let us use the lens formula. Very easy, lens formula. So that is 1 by f equals to 1 by v minus 1 by u. Remember, in mirror we had here plus, but in lens, sorry, in lens we have negative, right? So this is 1 by 10 centimeter equals to 1 by v, we have to find minus 1 by minus 15, right? Can we easily find from here? So 1 by v will be what? 1 by 10. This get cancels. So this will be minus 1 by 15. Understood? Anyone has any doubt in this? Okay. Next, just find the v, right? We'll take the LCM as 1. This is 15 minus 10. That will be 5 by 150 equals to 1 by v. So v will be 150 divided by v divided by 50. So that is divided by 5. 150 divided by 5, that is 30. So v equals to 30. Remember the units are in centimeter. Done? I am guessing there is some mistake. No? Because in convex lens, no, right. In convex lens, we should be positive. Yes, Maheshwari, 30, right. Prime. Stop it. Okay, yes, no mistake. Okay, so V is 30 centimeters. V is 30 centimeters, correct? So the nature and position we found. Position is V equals to 30 centimeter. What is the nature? The nature is in convex lens. This is a positive. The V is positive. That means the image is real. It is inverted. Real and inverted, right? And what will be the magnification? Now we have V. Can we easily find magnification as V by U, right? V comes out to be 30. U was minus 15. This was minus 15. So this is 2. So magnification comes out to be minus 2. Again, this also tells us that the image is real and inverted and enlarged right everyone? Okay, done. -2, yes, very good Maheshwari. Okay, let's move on to the next. We have another numerical that says an object is placed at a distance of 30 centimeter. An object is placed at a distance of 30 centimeter and u is always negative, right? Yes, object will be between f and 2f. Okay, Sharmaji. From the center of a concave lens, right? Now, of focal length 20 centimeter. What is the sign of focal length of concave lens, everyone? What is the sign of focal length of a concave lens? The sign of focal length will be what? Let me know. Use lens formula to determine the position of image formed in this case. We have to determine the position of image formed in this case. Negative. Very good. For concave lens as well as mirror, focal length is always negative. Right? Hi, Munivardit. Hi. Okay, so we just have to use the lens formula and let us see, you calculate it first or I do. Okay, let us do it. Use lens formula. 1 by f equals to 1 by v minus 1 by u. 1 by u is given as minus 1 by 30. 1 by v I have to find. Focal length will be minus 1 by 20. Right? We can just solve it. Minus 1 by 20. This is plus. So if it comes here again minus. Minus 1 by 30 equals to 1 by u. This becomes plus, right? So if I take it here, it is again negative. So the LCM will be 60. 20 into 3 will be 60 minus 20 into 3 will be 60, right? Minus 30 into 2 will be 60. So this is 1 by v. This is minus 5 divided by 60 equals to 1 by v. So v will be minus 60 divided by 5. That will be 12. So v is minus 12. The units are centimeters. Done? Everyone? Minus 12. Yes, Sharmaji did it first. Okay. Done? Can you tell again which Muni? Can I call you Muni? Right? So, if, see, a object is placed at a distance of 30 centimeters. So, u is minus 30. Optical center of a concave lens of focal length 20 centimeters. So, focal length is 20. But it is concave lens. So, focal length will be negative. Right? Now, we have to calculate the image distance. So, we will just use the lens formula. We put all the values in it. And after all the calculation, v is equal to minus 12 centimeters. Right? Okay, done. We have to determine the position of the image and we did it. Let us move on. Okay, everyone, whoever is present here, first go like the sessions. Go like the session, okay? And you can join this WhatsApp channel. We'll be giving all the PDFs of these numericals solved. From today, I'll give you all the solved PDFs in that WhatsApp channel as well. All the solved ones, okay, with answers. So go join that WhatsApp channel. There is a link in the description and then subscribe to the channel. Okay, we are done with the chapter human light. Okay, Munivardit, how are you doing? Everyone understood the whole chapter of light. We are moving to the chapter human eye. Okay? Yes, hi Archana, how are you? everyone? Okay, let us move on to the next chapter, human eye. If you have any doubt, okay, Sharmaji. If you have any doubt, let me know in the chapter light. Hi, Dheeraj. Done? The light chapter? Give me a thumbs up if all of you are done with the chapter light. With the chapter light. Done? Let's move on to the chapter human eye. Now this is a very, very easy chapter, you can say. Or if you don't study it well, it can be difficult because they will, see, Sharma Ji saying easiest chapter of physics. But we will still be doing some of the numericals that comes in the exam that can maybe trick you a little bit. Okay? Okay. Now, when we start this lecture with the human eyes, what, Dheeraj? Okay. How many of you see animes? How many of you watch animes? Okay, we have thumbs up, hearts. Okay, if you have, then you must have seen we have these kind of eyes. Okay, these we also see that a lot of human beings are friends, not in India maybe, but outside their genes they do have green colored eyes, blue colored eyes, right? What is the color of your eyes? I asked this last time. Now we have new students. So what are the color of your eyes? What is the color of your eyes? Has someone has a different tricky a different color? It's fine Sharma Ji. No, Dheeraj, I don't at this point. Okay. Done. So, when we do look at the color of the eyes, eye blue, you have blue, Rainy, you have blue color, and eye has black, brown. Now you had brown, Rainy, then it turned into blue. Okay, now, blue eyes, hypnotize, yes, great. Now, what we are going to see, we have all studied human eye the whole year. In this chapter, right now, I'll be asking you some of the questions that can come in the examination, that has come in the examination. Okay, Sharma Ji has rainbow colored eyes. Okay. Right? So, I'll be asking you questions and you will be telling me what part of the eye is responsible for that. Okay? Now, starting with the very first. Okay, Yadav Ji has blue color. Okay, fine. Everyone, come back, focus to the questions I'll be asking. I'll be asking the questions with the very first and it will be random. I won't start with cornea and then go to iris pupil. The first question on your screen, everyone, this is fastest finger first. The first question we have, what is the part of the human eye that is responsible to change the shape of our lens? That is responsible to change the shape, or you can say focal length of your eyes. Focal length of your eye lens. Everyone, you have 10 seconds. Ciliary muscles, we have the answer as Sharma Ji 1 point. Sharma Ji 1 point, the answer as ciliary muscles. Okay. Rainy is saying ciliary muscles, right? Great. Done? Understood? So the part of the human eye that is responsible to change or for changing the shape of focal length of the eye lens is called ciliary muscles. It changes the shape of eye lens. The shape of eye lens. Right? Okay. Very good. Eye lens, ciliary muscles, great. Rainy, what? Anaya, very good. Okay, blind spot located in diagram. What is the blind spot? Where is the blind spot? Okay, next question. Everyone, ready? Maheshwari, ciliary muscles, very good everyone. Next question on your screens, everyone. Not on your screens, but through me. Next question is, what is the part of the eye that changes, that is responsible for the color of your eye? Which part of eye is responsible for the color of your eye? Everyone, answer quickly. Which part of the eye is responsible for the color, for providing the color? Iris. It's not Irish, Sarma ji, it's iris. Okay, Shubham. Okay, iris. Reni is saying iris. Sharma ji again Irish. Iris. Archana Jadhav is also saying iris. Anaya is saying iris. Very good. Great, everyone. Oh. Great. Done. So the part of the eye that gives you these beautiful colors, these brown, these blue, these green, is called iris. Asta also said iris. Good afternoon, Ma Durga. Jai Ma Durga. How are you? Done. Next, which part is responsible to which part is responsible for the maximum amount of refraction that is happening in your eye? Maximum amount of refraction that is happening in your eye is responsible due to which part of the human eye? Cornea. Very good. Thank you, Shubham Maurya. You all are studying well as well. You are there. Your name is Kalpana. Okay. Welcome, Kalpana. Let me know the answer of this question. Which part of the human eye is responsible for maximum amount of refraction? That is cornea. Reni is saying pupil. Is it pupil? Everyone is saying cornea, pupil, and the correct answer is cornea. Very good. Cornea, Sudhanshu, Kalpana, all are saying cornea. Arun Thakur, Astha, Anaya, very good. All of you are doing great. Maheshwari, cornea. Okay, everyone gets one more marks. Who of you has full marks till here? Till now? Who has 3 out of 3? We have 3 questions, 3 out of 3, right? Okay. Batati hu. Wait. At the end, I'll write here big and big, okay? Okay, next we have the question. Okay, Devyanshu is back. Ma'am, why do moon appears white? Let us go into the human eye chapter and I'll tell you. Okay, Anaya has full marks. Sadex is also back. Okay, next question we have, which part of the human eye is responsible to maintain the shape of the eye? Is responsible to keep the eye in its shape. Which part is responsible to keep the eye in its proper shape? Let me know. Which part of the human eye, or which, yes, we have, okay, Reni now is going to answer everything pupil. Huh? Vitreous humor, Sharma ji is saying. Very good. Not pupil. Listen to the question carefully. Which part of the human eye is responsible to maintain the shape of eye? Sudhanshu is also saying vitreous humor. Divyanshu is also saying vitreous humor. Great. It is vitreous humor. Vitreous humor to maintain the shape of the whole human eye. Right? This is my human eye. Now in this, between the eyelens and the retina, there is this liquid. This whole place is filled with a liquid jelly kind of structure. That structure is called vitreous humor, and its main function is to maintain the shape of eye. Maintain the eye in a proper shape. Right? Gokul, Kalpana, Yadav ji. Yadav ji is saying Anchal. Sorry. Okay, Anaya. Hello, Asta. Very good. All of you said the answer as vitreous humor. Right. Then we have the next Gokul. Yes. Next question. Okay, we are done with ciliary muscles. We are done with vitreous humor, right? Done with the vitreous humor. Cornea, iris. Okay. Next we have, which part of the eye supplies oxygen? Which part of the eye supplies oxygen from air to my eye lens, and it does maintain the pressure on eye lens. It helps to maintain the pressure of eye lens, and it supplies oxygen from air to the eye lens. Which part is that? My name is Aditi Gokul. Hi Ishani Roy. Hi, how are you? Okay. What is this? Ayush, what are you writing? Aqueous humor. We have the answer as aqueous humor from Anaya, and then aqueous humor Gokul, Anaya, Divyanshu, Reni, and Sudhanshu. Okay, all of you. Ma'am, question repeat. Question is, which part of the human eye is responsible to provide oxygen from air to the eye lens, and it helps maintaining the pressure on the eye lens? That is my aqueous humor. Sudhanshu, aqueous humor. Very good, very good. Sakshi Yadav is also saying aqueous humor. Very good, everyone. Great. Gokul. Great. So, aqueous humor is again a jelly-like structure, not a structure, a jelly-like material that is present between cornea and eye lens. It is present between cornea and eye lens, and it helps provide oxygen from air to the eye lens and maintaining the pressure of the eye lens. Done? Okay, thank you. Welcome, everyone. Done? Next question. We are done with aqueous humor. Okay, next question. What part of the eye is called shutter of the eye? Okay, Sakshi, done. Which part of the eye is called shutter of the eye? We'll explain its function after. Which part of the eye is called shutter of the eye? Ma'am, I am from Kerala. I am from Punjab, but I have lived in Kerala for 2 months. Sugamano. Every time a person says that they are from Kerala, I'll ask them, Sugamano. Pupil. Okay, pupil. Sharmaji, Divyanshu. Reni is, Reni, right? Now you are correct. Now pupil is correct. Anaya, Sudhanshu. Okay, Sharmaji. Yes, Reni, Anaya. Everyone, great. This is pupil. Sakshi, great. So, the part of the eye which is called shutter of the eye is called pupil. Okay? And what is the function of pupil? Pupil helps to maintain the amount of light that is entering into my eye. So, when the light is too much, pupil shuts down a little bit, and when light is less, when we are entering in a dark room, light is less, it extends, it opens up, the shutter opens up, right? Okay, we have people from UP, Kerala, very good. We have all India here, okay? Right, so pupil control the amount of light entering into the eye. Very good, everyone. Now, iris controls pupil. This is a very important point. Which part of the eye controls the pupil, helps the pupil to control the amount of light? That is iris. Okay? Sharmaji is from Assam. Are you from Assam, Sharmaji? Done? Okay. Anaya is also from Kerala. Great, everyone. Okay, so we are done with pupil. Okay, 3 things are left. What is the screen of the eye? Okay, what is called as the screen of our eye? Okay, now this is very basic. I'm going to answer, right? The answer is retina. Now you let me know what are the 2 kinds of cells. What are the 2 kinds of cells present on the retina? What are their names? Divyanshu ji is from Uttar Pradesh, that I know. Sharma ji is from Assam. Okay. Kalpana is also from Uttar Pradesh. Retina, Anaya, very good. Gorakhpur. Rods and cones, very good. Retina, everyone, great. Retina is the answer. and rods and cones is the answer. Convert light into electrical signals which are then sent to brain and optical nerves allows us to see. Very good, very good. Okay, done. Great. Rods and cones are present on our retina. These are light sensitive cells. They get active when light falls on it. They convert light into electrical signals and they pass on that to optic nerve, which takes them to the brain. Oof. Okay. Now optic nerve, this is just a nerve. This is just a nerve that takes the signal, carries the signal from these rods and cones cells and pass it to the brain. And one of the most important parts, almost all the parts of the human eye are important, but the most important part of the human eye is what? Is my crystalline lens. Which lens is this? Concave lens or convex lens? Oh, Sharma ji just read my mind. Which lens is this? Concave lens or convex lens? Thank you, Kalpana. It is all in your efforts as well, right? I'm here just for you guys. Eye has one blind spot, Divyanshu. Oh, I am from Kerala, Kozhikode. Kozhikode. I know how to pronounce this. My friends taught me one day. Convex lens, convex, convex, convex. Very good. Divyanshu, Anaya, Sudhanshu, Reni. Very good. Kalpana, Aman. You are a superhero, Sharmaji. That is great. Okay. Sakshi is also saying convex lens. Very good, everyone. Convex lens is the lens which is present in our eyes. Done? Great. We are done with all the parts of the human eye. And now will you remember these parts as well as their function? Thumbs up. Now anyone has any doubt in the parts of the human eye? Let me know. We'll solve it and we'll move it to the next part. We'll do this whole chapter like this. I'll ask you questions, you tell me the answer. Instead of me explaining, you tell me the answers, right? Teach any Punjabi word. Punjabi word. I love one word of Punjabi, that is jawak. Jawak means kid. So you are my jawak. How are you, Jawako? Okay. Okay, we have thumbs up. Very good, everyone. Done. Let's move on to the next. We have power of accommodation. Okay, let me ask you the questions now. Okay, let me ask you the questions now. Ciliary muscles, right? We studied about ciliary muscles, everyone. You told me that these are responsible to change the shape of eye lens. Now, my eye lens can either have a greater focal length. It has more focal length, or it has less focal length. Now you have to tell me in which case the ciliary muscles will be contracted. When the ciliary muscles are contracted, will the eye lens have greater focal length or will the eye lens have less focal length? Let me write it here. When the ciliary muscles are contracted, will the eye lens will have more focal length or less focal length? The ability of the eye lens to adjust its focal length is called power of accommodation. Very good, Prakash. Power accommodation. Right. Less focal length. Okay, Sharma ji is saying less focal length. And power of accommodation. Yes. Less focal length. Very good. Anyone else? If the muscles are contracted, if the ciliary muscles are contracted, then they will be more focal length or less focal length? Okay, we have the answer as less focal length. So, if the muscles are contracted, they will have less focal length. And if they have less focal length, will we be able to see nearby objects clearly or far away objects clearly? Yes, Nikhil, what is your doubt? Ma'am, once more. So, once more, what once more? When ciliary muscles are the ones that control the shape of the lens, that controls if it has less focal length or more focal length. So, if ciliary muscles are contracted, will they have less focal length or more focal length? They will have less focal length. They will have less focal length, something like this, and they will be able to see nearby objects clearly. Nearby clearly. Very good, everyone. Very good. Less. Sudhanshu, Divyanshu, Sharma ji. Very good. Very good. Great. Now, Sakshi is also saying near. Second case is what? When the muscles are relaxed. When muscles are relaxed, then will the focal length be more or will the focal length be less? Now you know the focal length will be more, right? Focal length will be more. Done. So for relaxed, we will have more focal length. If we have more focal length, we will be able to see nearby objects clearly or far objects clearly. If we have more focal length, if we have relaxed ciliary muscles, will it be having more focal length or less focal length? Okay, Aman. Bye. Oh, your online gaming friend is also from Punjab. Okay. Power is high when focal length is high. Let me come back to you. More far objects. Very good. Very good. Sri Vignesh. Hi, Vignesh. Vignesh, Sharma ji. Everyone, very good. Very good. They will be able to see far objects. Why can't I write? What happened? We will be able to see far objects clearly. Done, everyone? Done with the part of power of accommodation? You will remember it now? Okay. Okay, Sakshi. Okay. Hi, Vignesh. Oh, how do you know Azamgarh? Bhai, Sharma ji. You are from Assam. You know where Azamgarh is. Okay, next we have defects. More F, less thin. Oh, yes. Let me also explain that whenever the focal length is more, that means the lens will be thin. Great, Sharma ji, very good. Whenever the focal length is more, the lens will be thin and we will be able to see far objects, muscles will be relaxed. Whenever the focal length is less, the lens will be thick, and as the lens is thick, we can see nearby objects clearly, and that is because the ciliary muscles are contracted. Right? Okay. Then moving on to defects. First defect. In which defect can I see nearby objects clearly but not the far ones? In which defect can I see nearby objects clearly, but far ones I can't? Which defect is that? Which defect is that? Thank you, Vignesh. I'm so glad that you are able to do it. That we are able to help you. Sudhanshu is saying myopia. Sharma ji is also saying myopia. Rukmini, Divyanshu, everyone is saying myopia. Okay. Great. Nearsightedness. Yes. Maheshwari, I remembered your name. So sorry for that. Can you tell me your name again, please? Okay, Maheshwari, Nikhil, Kalpana, Sharma ji, Anandhero. Acha? Okay. Sakshi, very good. Everyone is saying myopia. That is correct. In myopia, it is also called nearsightedness. That means, let me tell me the other defect in which you are able to see faraway objects clearly but not the near ones. This is also called sightedness. nearsightedness, myopia, which is the other defect in which you cannot see nearby objects clearly, but far ones are clear. Far ones are clear. I really don't know, Sharma ji, to be honest. Why you are having a crown? You are a good student, so you have a crown. Okay? Hypermetropia, myopia, no, myopia, hypermetropia. Very good, Sharma ji, Vignesh, Maheshwari, Rukmani. Great. Everyone is saying Priyadarshini. Great. So this defect is called hypermetropia, and it is also called what? It is also called long-sightedness. It is also called long-sightedness. Done? Now, next part of this question. Let me reframe the question. Okay. Next part is where the image is formed. Image formation. In normal cases, the image will be formed on, I have done this a very bad job in making this. Let me just make this again, okay? Just a second. Okay, so first is image formation. This is hypermetropia. And this is myopia. In hypermetropia, where the image is formed? On the retina, behind the retina, or in front of the retina? Let me know where the image is formed. On the retina, behind the retina, in front of the retina. Arey, why? Ma'am, bifocal length. Yes, I will draw the diagram of bifocal length. Don't worry. Myopia before the retina. Okay, retina. I am asking for myopia. Is it in front of the retina or behind the retina? So for myopia, it is behind the retina. Okay. For myopia, is it behind the retina or in front of the retina? Did you all sit collectively and gave the wrong answer? Because in myopia, the image is formed in front of the retina, my friends. In myopia, yes, Sharma ji, in front. In myopia, the image is formed before the retina. It's either in front of the retina or behind the retina. In front of the retina, in hypermetropia, it is behind the retina. Very good. So, image formation in hypermetropia, it is behind the retina. It is behind the retina. And in myopia, the image formation is in front of the retina. In front of retina. Done? Understood? Okay, next question. What are the causes of this defect? What are the causes of this defect? What are the causes of this defect, everyone? Let me know fast. The causes of these defects. What is the cause of myopia? Let me tell you what is cataract. Let me be done with all this myopia and hypermetropia, then we'll move on to all. Okay? Itta sara. No, whatever they asked you, I'm here to revise you, right? That whatever they've asked you, they'll probably ask you the causes of this defect. This particular point, the causes of this defect. This is very important, okay? Cloudy eye lens, yes, equals to cataract. Because of long exposure to UV rays, you have seen that cataract mostly happens in old age. So because of long exposure of UV rays, a milky like a structure, a cloudy thing sits on your retina, on your cataract, and that is on your, hey Bhagwan, on your cornea, and that is called cataract. Okay. Myopia, elongation of eyeball or excessive curvature of the eye lens. Yes, very good. So for myopia, it is first excessive curvature of eye lens or elongation of eyeball. Elongation of eyeball. Very good. For hypermetropia, we have focal length decreases, elongation of eyeball. That is for myopia, Siddhanshu. That is for myopia. Yes, Priyadarshini, myopia is for elongation of eyeball. Hi, Anu Mishra, how are you? Short eyeball, yes, for hypermetropia. Okay. Okay, so for hypermetropia, okay, did I write it wrong? Yes. Wait. This is for myopia. Right, correct, everyone. Now, for hypermetropia, what are the causes? Hypermetropia, eye lens is long. Hypermetropia, focal length becomes too long, eyeball becomes small. Yes, very good, Sharmaji. Hypermetropia, eye lens, no, focal length of eye lens, Rukmini, focal length of eye lens is long. Okay. So first is focal length of eye lens increases, or my eyeball, the eyeball gets shortened. Due to some accident or something, because normally the shape of eyeball remains intact, but because of some accidents or something, your eyeball can get shortened, right? Now the final and the most important round. The final and the most important, what lens is used to correct this defect? The corrective lens. The corrective lens we use to correct these defects. For myopia, which lens do we use to correct the myopia defect? Hi everyone. Okay. Oh, again I have to filter the comments. You guys are very naughty. Which lens do we use to correct myopia and hypermetropia? Okay, so to correct hypermetropia we use convex lens. Sharma ji, Rukmini, very good. Rukmini, and for myopia we use concave lens. So Danshu is saying hypermetropia convex, myopia concave. Very good. Myopia concave. Yes, there, Vignesh, everyone listen carefully. There will be classes from 21st, 22, 23, 24. All 4 days we will be covering the whole science, physics, chemistry and biology. Do not worry about that. Along with PYQs, quick revision, repeated questions, everything. Okay, great, everyone, very good. Prakash Yadav, Sakshi Yadav, very good. So for hypermetropia we use convex lens. And for myopia, my friend, we use concave lens. Very good. Great. Let's move on now. Let's move on to the next. We have a last defect, that is presbyopia. In presbyopia, the person is not able to see nearby as well as far away objects clearly. Why this happens? This happens because of weakening of ciliary muscles, gradual weakening of ciliary muscles. See, as you get old, all the muscles in your body get weak. right? So ciliary muscles also gets weak and they are not able to hold the lens properly, and it is diminishing flexibility of the eye lens. That is why the eye lens flexibility diminished. Yes, Kalpana, I know you gave the answer. I read your answer. Kalpana also gave the correct answer. Very good. Done. So to correct this, we use bifocal lens. What are the diagram? The diagram you have, see, which diagram are you talking about? Ray diagram or the diagram of bifocal lens? Yes, very good, Sharma ji. Eye lens loses its flexibility. So in the bifocal lens, we have these two parts. So the lower part, this part is used for reading. It is used for reading, and hence, see, this part is used to see nearby objects clearly. How do we see nearby objects clearly? By using convex lens, right? By using convex lens. And the upper part is to see distant objects clearly. It is to see distant objects clearly. And to see distant objects clearly, we use concave lens. We use concave lens. Done? This is the diagram. Yeah, you can draw this. Okay? You can draw something like this. Done? Bifocal lens. Yes, Ma Durga, Kalpana, Sakshi, Sarma ji. Haan. Very good, very good. Lower convex, upper concave. Rukmani, very good. Done. Done? Okay. Next we have a question. It is observed that the power of an eye to see nearby object as well as far off objects diminishes with age. Give reason for the above statement. Name the defect that is likely to arise in such a condition. We just did the same question. And you see, a same question has come. Same question has come. Right? A person cannot see nearby as well as far away objects clearly. What is the defect? The defect that we just studied. Yes, Sharma ji, the defect is presbyopia. Sudhanshu, Sakshi, okay. Great. The defect is presbyopia. Very good. Due to old age. Yes, presbyopia, Sakshi, Rukmani. Okay. So, this is presbyopia, and we know that the cause is due to gradual weakening of ciliary muscles. Gradual weakening of ciliary muscles. And what else they have asked? Name the defect and give reason. Give reason is due to old age. Done? Okay, very easy. Next, move on to the next. And we have a very important question for you guys. Weakening of ciliary muscles. Very good. Kalpana. Great. Weakening of ciliary muscles. Eye lens loses its flexibility. Sharma ji. Great. Bifocal lens is used. Yes, Rukmani, correct. To correct this defect, bifocal lens is used. Sona is saying the defect is presbyopia. Very good, very good. Now, listen, look at this question very carefully. Focal length of lens is 10 centimeter. Okay, focal length of any lens, of a random lens, is given as 10 centimeter. Write the nature of the lens and its power. We have to write the nature of the lens, and then we have to find its power. If an object is placed at a distance of 20 centimeter, then they have asked if an object is placed at 20 centimeter from the optical center, according to the new Cartesian convention, what will be the sign of magnification? What will be the sign of magnification? Let me know. What do you think? Oh, we have the answer as 10 diopters. Okay. Your answer was correct. Yes. Sakshi. It was correct. 10 diopter. Divyanshu is also saying 10 diopter. Okay, let us see and tell me what is the sign of magnification. What will be the sign of magnification? Sudhanshu is saying power as 10 diopter. Nature of lens is convex. Okay. Now what we have to see in this case is, first you have to see the sign of focal length. The sign of focal length, that is in this case positive. So which lens has positive focal length? That is, ma'am, convex lens. Convex lens has positive focal length. Great. Then we have to, so we know the nature, that is convex lens, right? Nature is convex lens. What is the power? Now be very careful. For power you have to first convert focal length into meters, right? So in here this is 10 centimeter. What will be the meters? This will be 0.1 meters. Now focal length is, power is 1 by focal length. That will be 1 by 0.1. That will be 10 diopters. So power here is 10 diopter. Very good, all of you. Done? Okay, then we have to find the sign of magnification. See very carefully, this is a convex lens, right? This is a convex lens. Now convex lens makes both real inverted image and virtual erect image. So we have to actually see, right? What is the sign of magnification? What will be the sign of magnification, right? So see clearly, let me calm down. You don't have to probably solve it till the end. We just have to tell the sign of magnification. See, focal length is 10 centimeter. Now the object is placed at a distance of 20 centimeter. Look at this very carefully. Focal length is 10 centimeter, right? And the object is placed at minus 20 centimeter, right? Done. Now radius of curvature will be 20 centimeter. Right? So that means this object is placed at 2f1. The object is at 2f1. Everyone agrees? So the object is at 2f1. Welcome Tanvi ma'am. Tanvi ma'am is here, everyone. Come Tanvi ma'am. Everyone wants to say hi. Jaldi aao. Come. Arey? Everyone, hi, say hi to Tanvi ma'am, everyone.
Hello, study.
Okay, focus, back on. So focal length is 10 centimeter. Object is at minus 20 centimeter, right? Okay, done. Now see very carefully, object is at 2f1. See, this is my convex lens, okay? Focal length is, this is f1, this is 2f1, this is f2, this is 2f2, right? Focal length is 10 centimeter. That means this distance is 10 centimeter and this distance is also 10 centimeter, right? This is equal, okay? Now the object is at minus 20 centimeter. That means it is at 2f1. This is my object. Right? If the object is beyond f1, that means the image will be real and inverted, right? That means the sign of V will be what? That means the image will be on the other side. Image will be here, right? If the object is at 2f1, image will be at 2f2, right? So the image is at 2f2, correct? So the image is, V is again 20 centimeter, but now positive because it's real and inverted, right? Now can we directly find the sign of magnification V by U? V is 20, U is minus 20, so that is minus 1. So magnification is minus 1. You don't have to search through it. Done? Negative sign is M. Yes, very good. Done, everyone? Okay, let's move on to the next question. Same size, enlarged, right? Same size and enlarged, Sudhanshu? It will be of same size, 20. Yes, very good, Maheshwari. It will be of same size, not enlarged. The image will be at 2f2, it will be real and inverted, and magnification will be -1. Very good, everyone, very good. Very good. Okay, next let's move on to the next. We have what is a rainbow. This is a PYQ, so make sure you don't skip questions like this and use proper keywords. What exactly is a rainbow? Done? What exactly is a rainbow? So what exactly is a rainbow? A rainbow, ma'am, is a natural spectrum of sunlight. It is a natural spectrum of sunlight formed after rainfall due to dispersion. See these words. You have to write these words very carefully in the exam. You have to mention that this is because of dispersion. Done? Internal reflection and refraction of sunlight by water droplets. Done? Everyone understood? Everyone understood? Dispersion, reflection, refraction. Very good, Divyanshu. Then now we have to draw the diagram as well. So how will you draw the diagram? You don't have to use a compass or something for this. Just draw a water droplet and a ray, sunlight is coming, right, at this surface. For the first refraction, for the first surface, it will be refracted and dispersed. So it will be refracted and dispersed into 7 different colors, right? And after that it will get refracted. It will get reflected. Total internal reflection. Here it is refraction and dispersion, right? Then at this, the other part of the water droplet, it will get totally internally reflected, and while coming out, it will get refracted again. It will get refracted again. Done? Hey Bhagwan. Done, everyone? Understood? Let's move on to the next question. This was easy. Rainbow is formed on the opposite side of the sun. Yes, you can write that as well. Okay? Okay. Next, we have name the type of lens required by the person for the correction of the defect of vision called presbyopia. Very easy. What is the lens that is used to correct the defect? Which is the lens that is used to correct the defect, that is presbyopia? Oh, bifocal lens. Very good, everyone. So the lens which is used to correct presbyopia is called bifocal lenses. Write the structure of the lens commonly used for the correction of this defect. So we know the structure is simple. The lower part is convex lens. Which lens? The lower part is convex lens to see nearby objects clearly, and the upper part is concave lens. It is concave lens and it is used to see distant objects clearly. Right? Understood? Done? Rukmini is also saying bifocal lens. Sudhanshu, Madurga, Kalpana. Yes, everyone. Great. Next, let's move on to the next question, that is the image distance from the eye lens. The image distance from the eye lens in the normal eye, when we increase the distance object from the eye, does it increases, decreases, remains unchanged, depends on the size of the eyeball. What happens to the image distance when object distance is changed? Oh, we have lots of emojis from Sharma ji. Thank you, Sharma ji. Let me know. There are 4 options. The image distance from the eye lens in the normal eye will, when we increase the distance, so we are increasing the distance of objects. What will happen to the image distance? remains unchanged because retina is fixed. B, Sudhanshu is saying B, okay. Komal is saying A. Kalpana is saying C, C, B, C, B. Okay, okay, we have two answers. Okay, listen to this very carefully, okay. You have this object, you have this tree, okay, and you are standing here. So your eyes are here, right? Your eyes are here. Now, if this is a tree and this is a small kid and you have a book in your hand, all have different object distances, right? But image is forming on your retina, right? Image is forming on your retina, right? Okay, yes. Sharma ji, Ma Durga, same team. Correct. So the actual answer will be it remains unchanged because our retina is fixed. Exactly how Sharma ji has said, our retina is fixed. That means the image distance is always fixed. Done? Okay. Next question we have, the far point of a short-sighted person is 1.5 meters. We are given the far point. The far point is 1.5 meters. Find the focal length. We have to find the focal length and power and nature of the remedial lens. Can you guys solve it? Okay, let me give you a hint. So the hint is actually what you have to do. Whenever you get a questions like this, where it is written far point or near point, and you have to find the focal length of, you have to find anything, focal length, power of corrective lens, or remedial lens, then in that case the new far point, the far point that is given, this 1.5, this is given, right? This will be your image distance. This will be your image distance, and it will always be negative. For corrective lens, it will always be negative. Yes, yes, Kalpana, I remember. Okay, done. Minus 0.6 diopters. We already have an answer from Rukmini. Okay. What is happening in this comment section? Okay. Yes, Praveen, what is the doubt? Done. What you have to do whenever a far point or a near point is given, that far point or near point will become the image distance of the corrective lens. It will be the image distance of the corrective lens. Done? So we have to find the focal length, right? Now, in case of far point or short-sightedness, short-sightedness means this is myopia, right? And we know in normal eye, in myopia, far point shifts. Now far point shifted to 1.5 meter, but from where? It shifted from infinity to 1.5. So you will be infinity in case of myopia or far point. Done? Good afternoon, Kamal. How are you? Komal is also saying minus 0.62. Remedial lens has a focal length of minus 1.5 ampere. A. Of minus 0.067, and it is a concave lens, it is a diverging lens. Okay. Focal length is minus 1.5 meter. Good afternoon. Okay, let us solve this, right? Which has most focal length? What are the options? Yuvash, Praveen. Okay, great. Now you have you have V. U is infinity, V is 1.5. V is minus 1.5 meters. Remember the units, whatever is given. If it's meter, you have to write meter. Let us use the length formula, right? Because we have to find the focal length. This is simply minus 1.5. This is minus 1 by infinity. So 1 by infinity is equal to 0, right? So 1 by focal length will be minus 1.5 meters and focal length will be minus 1.5 meters. Okay, great. Done. Next, power, you just have to find the power. Now in here focal length is in meters, so 1 by focal length, that will be 0.1.5. This is minus. Remember to apply the minus sign. Do not forget the minus sign. This will be 10 by 15 and our students are saying this will be 0.62. That is correct. 0.62. Done? Everyone? Okay. Hi, I am doing great. Thank you. Okay. 0.6, that will be 15. 6 will be. Okay, this will be 0.067. This will be 66 and then 0.67. You all, not meters, it will be diopters. Done? Right? Then that is it. What is the nature? Since the focal length is negative, so the nature will be concave lens. Understood, everyone? Yes, the minus 0.66 hoga, Sharma ji. Yes, correct. Hi Pooja Maheshwari, you are attending the class for the first time. Welcome to the class. Your name is Diya Maheshwari. We are doing the chapters. We are, ma'am, I'm telling her. Yes, I saw 0.06. Very good. Okay, no, I haven't. I will in some time. I'll eat. Can I call this? Okay, done. Yes, Diya Maheshwari, welcome to the class. We are doing, right now we are doing the numericals of the chapter Human Eye. This is a small chapter, but we should not miss it, okay? Because it will give us some numericals, right? Okay, let's move on to the next. We have, after tracing the path of a ray of light through a glass prism, although I haven't taught you glass prism right now in this session, but I know you are smart kids, so do it, okay? My name is Aditi, everyone. Okay. अभी book नहीं है, okay. Okay. Let's move on. After tracing the path of a ray of light through glass prism for 4 different values of angle I, every ray diagram was analyzed and the following conclusions were drawn. On drawing the prism, the ray bends towards its base. On drawing the prism, on entering the prism, the ray bends towards its base. While emerging from the prism, the ray further bends towards the base. The emergent ray bends at a certain angle to the direction of incident ray. Which of these is correct? Hello Trey, welcome back. Long time no see. Yes, where were you? No, Tamil Selvi, I don't actually. What is that? Maheshwari Ji is saying C, Devanshu is saying 3, Sudhanshu is saying 3. Okay, ma'am, the screen is blur. Is it, everyone? I think it is not. Maybe you check your connection or something. Okay, let us see. Right, let us make the diagram of prism first. See, this is a prism, right? My ray goes like this and it, of course, it is bending towards the prism. It is bending towards the base. This is the base of the prism. So the incident ray is bending towards the base. So first is correct. A is correct. Then on the second, this is the normal. It is again bending towards the base. right? So again it is correct. So second option is correct. The emergent ray bends at a certain angle to the direction of incident ray. Let me explain what this exactly means, right? See carefully. This incident ray goes something like this, and this incident ray, if we extend it, between this there is an angle of deviation, right? Between the extended incident ray and the emergent ray there is a, yes, 4, okay, there is an angle of deviation. So what this means is that emergent ray, my emergent ray, bends at a certain angle. It is bending at some angle to the direction of incident ray. This is the direction of incident ray, but it is bending at a certain angle to the direction of incident ray, right? Done. So the actual answer is 3 is correct. 4 is the actual answer. 4 is the actual answer, everyone. Done. Lokendra, get some medicine, get some rest. Okay, yes, 4 is the correct answer. Sharma ji, Trey, very good, very good. Okay, let's move on to the next. We have a next question. We have near points. The near point. Okay, Sharma ji. Okay, I know. The near point of an eye of a person is 50 centimeter. Now the near point is given. What did I tell you when the near point was given? So every time near point or far point is given, that becomes your V, right? Everyone? Pooja is saying option 4. Yes, yes. So this becomes your near point, right? Done. Now V is 50 centimeter and it is always negative. It is always negative. Find the nature and power of the collective lens required by the person to enable him to see clearly. Now, since it's a near point, everyone listen carefully. We did far point. In that U was infinity, right? Near point. Now, near point of a normal human eye is what? It is 25 centimeter. Right? So in this case, U will be minus 25 centimeters. Right? Now we just have to find the nature and power. From this, can you find lens formula? From lens formula, can you find focal length? 1 by F equals to 1 by V minus 1 by U. 1 by V is minus 1 by 50 minus U is minus 25, right? So this is minus 1 by 50 plus 1 by 25. That is 1 by focal length. From here, if you solve this, if you take the LCM, LCM will be 50. That will be minus 1 plus 2 equals to 1 by 50, right? So focal length is 50 centimeters, right? Now focal length. Which lens has focal length 50 centimeter? Positive image distance. Okay, everyone understood this question? Whenever near point is given, you have to take that as the image distance. Done? Everyone, give a thumbs up. And the power, yes, power is, oh, we have 2 options. We have 2 answers. Power is 0.5 diopter and power is 2 diopter. Sudhanshu and Rukmini. One of you is correct. This will come for 2-3 marks. This question can come for 2-3 marks maximum. Okay? Okay, we have lots of answers. We have focal length 50 centimeter, 50 power 2 diopter. Okay. First. I am in which class? I am a teacher. I am done with classes. Okay, so focal length is positive. So that means the lens is convex lens. First and the foremost, the lens is convex lens. Now, the power. See, to find power, we have 2 formula. 100 by F, then when F is in centimeter. And 1 by F when F is in meters. Here, the F is in centimeter. So, we have to use this formula, 100 by 50. Right? So that will be 2 diopters. So power is 2 diopters. Understood, everyone? Done? Convex lens, Sudhanshu, Rukmani, very good, very good. Okay, we have thumbs up, very good. Power is 2 diopter. Komal, yes. Okay, power is 2 diopters, very good, very good. Let's move on to the next. Let's move on to the next question. Okay. Hi Anshika, how are you? Stick? No, I don't know what stick is in your language. Okay, next question. A student needs spectacles of minus 0.5 diopter. So power of the spectacles is minus 0.5 diopter for the correction of his vision. This is the power of corrective lens, of course, but still the power of corrective lens, right? Next we have, name the defect of vision of the student is suffering from. Which defect is the student suffering from? Everyone, let me know. Let me know which defect the student is suffering from. Hi Anup, how are you? Ma'am, all-rounder. How? Okay. Okay, myopia. Okay, Rukmini is saying that the person is suffering from myopia. Concave lens, Komal is saying. Okay. Okay, right. So, how do you have to go through this? Power is, sign of power is negative. Sign of power is negative. That means focal length will also be negative. Now, which lens has negative focal length? That is concave lens. That is concave lens. Good, right? Now, defect is suffering from, find the nature and focal length of the corrective lens. We have to find the nature and focal length of corrective lens. Nature is concave lens. And how will you find the focal length? That is simply 1 by power. Power is 0.5 but negative, minus 0.5. So that will be 10 by 5, that is 2 meters. Remember, the focal length is in 2 meters here because power is in diopter. Done. Okay, everyone, done? Yes, ekansh, yes, 2 diopter. Focal length is 2 meters, sorry, yes, focal length is 2 meters. Very good, all of you. List 2 causes of this defect. What are the 2 causes of myopia? What are the 2 causes of myopia? Yes, sorry, minus. Yes, Ekansh, it is minus. Rukmini, minus. Yes. What are the, yes, I applied Simran negative sign, sorry for that. Oh, okay. Selvi. No, I don't know the founder actually. Like by face. Okay. Excessive curvature and shortening of eyeball. Curved off cornea. Wait, think about it. Elongation of eyeball, not a short eyeball, elongation of eyeball, right? So the 2 causes of myopia and its 2 causes are excessive curvature of eyeball, and the second is elongation of eyeball. It is elongation of eyeball. Correct, everyone? Yes. Sudhanshu causes elongation of eyeball and contraction of eye lens. Yes, that is correct too. Short focal length. Yes. Very good. You can also write short or decreased focal length of eye lens. Decreased focal length of eye lens. Okay, great. Let's move on to the next. We have the near point of a person suffering from hypermetropia is 75 centimeter. See, again, near point is given. Now what will you take V? What will be the value of V, everyone? Hypermetropia, devotion. See, hypermetropia is a defect in which you cannot see nearby objects clearly, but can see distant objects clearly. Okay? And in this, what is the cause of this? Because of shortening of eyeball, or increased focal length of eye lens. In this, the image is formed behind the retina. And the corrective lens we use is convex lens. Oof. Done. Devotional edits. Okay, infinite. -75. Yes, Rukmini, very good. The V will be, see, every time you are having numericals like near point, far point, so the near point that is given will be your V. So V will be -75 centimeters. Calculate the focal length and power of the eye lens. We have to calculate the focal length and power of the lens required to enable him to read the newspaper, which is kept at 25 centimeters. So newspaper is kept at 25 centimeter. So that will be my object distance. Can you solve this question? We have to find focal length. We can do that by using lens formula. Right? This is -75 minus of -1 by 25. Right? So this is -1 by 75 plus 1 by 25. 1 by F. Can you solve it from here, everyone? V is -75, U is -25. Sudhanshu, very good. Why it is negative? See, what is the actual point of using this lens? What it does is, see, we use convex lens for hypermetropia. So what it does is, my near point is at 25, but the normal human eye, near point is 25 centimeter. But for hypermetropia, the near point has shifted far. So this lens, what this does is, first this makes the image of this object at my near point. Then from my near point, the rays will go into my eye lens. So for this image is, this is the object and this is the image. That's why we take it as minus, because they are in the same side. Hi Sanya, how are you? Okay, understood? Okay. Done? Yes. F will be -37.5 centimeters. Sudhanshu is saying. Minus or plus? Minus or plus? So 1 by focal length is 1 by 75. This is -1 by 75 plus 1 by 25. This is minus. So we'll take 75, right? This will be -1 plus this is 3. So 2 by 75, 1 by focal length. So for negative sign is not there, Sudhanshu, right? So that is 37.5. So focal length is 37.5 centimeters. Done? What will be the power? What will be the power of this? Power will be 2.6 diopter. Okay, Komal is saying 2.67. Rukmini is saying 2.6. Arey yaar. Okay, done? Okay, Siddhanshu, it's fine. Just be careful, okay? Now, for power, we just have to do 1 by focal length. But this is in centimeter. So, we have to do 100 by focal length, right? So, that will be 100 divided by 37.5. And this will be 2.6666. And that will be 2.67 diopters. Done? Anyone has any doubt? Magnetic effects of electric current, we also already covered. Duggu pencil, we already covered, so you can go check that out, okay? We covered with all the questions and explanation. Hi Akshara, Hi. Ranjana is from Sikkim. Hi. Okay, done? Okay, let's move on to the next. We have MCQs for everyone. Give me the answer of this question. The focal length of the eye lens increases when muscles are relaxed and lens becomes thinner. B. Contract, lens becomes thicker. C. Relaxed and lens becomes thicker. D. Contract and lens becomes thinner. What is the answer to this question? Come on, fast everyone. Hey, this free fire will... Okay. Everyone, what is the answer to this question? What Lokendra? What are you talking about? Akshara is saying A. Okay. A, ma'am. Yes. Okay. So, yes, you are correct. We just study, right? Focal length of eye lens when increases, that means my ciliary muscles are relaxed. That means the ciliary muscles are relaxed and the eye lens became thinner. It became thinner, and that is why focal and ciliary muscles are relaxed and eye lens is thinner. Correct? No, it's not B, it's A. Focal length increases when muscles becomes relaxed and eye lens becomes thin. Done? Everyone? A option. Yes, very good, Rukmani. Okay. Next, let's move on to the next. We have, I guess this is the last question for today. Yes, this is the last question for today, and we'll just study about rainbows and stuff. Okay? Yes, you were right, Akshara. Okay, done. Study the diagram below and answer the following. Name the defect of vision depicted in the diagram. What is the defect of vision that is depicted in this diagram? Everyone, give me the answer. See the diagram very carefully. See the diagram very carefully. What is the defect that is being depicted in this diagram? Solo edits. Hi, solo edits. Let me know which is the defect. Ma'am, maths live start. Huh? Not now. Maths live will be from 5 p.m. Hypermetropia, focal length is long. Very good, Rukmani. Sudhanshu, Komal. Yes, Akshara is also saying hypermetropia, use convex lens. Okay, yes, great. Tilu Kumar, hello Tilu Kumar. Hypermetropia, eyeball becomes short. Very good, all of you. Great. This is hypermetropia. Why? Because the image is being formed behind the retina. This is my retina. The image is formed here. So the image is formed behind the retina. Two causes of the above defect: because of the shortening of eyeball or increase in focal length of the eye lens. Very good. Rukmani is saying that draw a ray diagram for the correction of above defect. Yes, you will use convex lens to correct the above diagram. How will you make the diagram? Diagram is very simple. You just make a eyeball and this is your lens. Now you can make a bulge out as well. Now this is your near point. If the near point, from the near point the rays are meeting backwards. So this is the defect. How will you correct it? How will you correct this defect? By using a convex lens. So what does this does is, by using a convex lens, now if this is my near point, this is the normal near point and this is the new near point, N dash, right? So the rays will go, it will get converged, a little bit converged, so they goes back to this point. Now this is my near point. So from here the rays will go into my eye lens and the image will be formed on the retina. Done? Everyone? Hi Ranjana, how are you? Okay, everyone, done? Okay. Next, we have this topic, that is refraction of light through a prism. Listen very carefully, very important. A light ray comes, right? A light ray comes and refracts from the first surface. You make a normal, it bends towards the base. So this is angle of incidence, this is angle of refraction. Again you make one more normal, it bends towards the base. This is angle of emergence. So this is extended angle of incidence, extended ray, extended incident ray, and emergent ray, and this angle is called, what is this angle called? The angle between emergent ray and the angle between extended incident ray, it is called what? What it is called? It is called angle of deviation. This is called angle of deviation, and the E is called angle of emergence, angle of refraction, angle of prism. This, the angle between two refracting faces of the prism is called angle of prism, and I is angle of incidence. Very good, Rukmini, it is called deviation. Very good, very good. Emergence, yes, Sudhanshu. Emergence is this angle, Sudhanshu. I am asking the angle between incident ray, the angle between incident ray and emergent ray. This one, this angle is called angle of deviation, right? Ranjana, I am from Punjab, Ranjana. Okay? Okay, let us move on to the last topic. This is dispersion of light. So the splitting of white light into its constituent 7 colors is called dispersion. Okay? Happy Rose Day, Akshara. Right? Dispersion of white light into its constituent 7 colors is called dispersion. So this color, it is Vibgyor. At the lowest part we have violet color, and the uppermost we have red color. Right? Done. Now one day Isaac Newton came and he said, how can you study this easily? You just place a prism and you split the white light into 7 colors. No. I won't let you study this easily. So what did he do? He placed an inverted prism. This is a prism. He placed an inverted prism in front of the correct prism, right? So a white light comes, it splits into 7 colors. This much we know. So he placed an inverted prism in front of this splitted light. What did he saw? He saw that when it passes through the inverted prism, it merged back together. The dispersed white light, it merged back together, right? And the ray that came out was a simple white light. So this is a very important, they can ask you, right? Isaac Newton, yes. Done. Next we have small concepts. This rainbow we already studied. White light comes, it gets dispersed. Inside it gets totally internally reflected and then comes out. So first refraction, then dispersion, then reflection, then refraction. Done? Understood the chronology? And we have small topics, scattering of light. Scattering is the deviation of light. Light goes in a straight path, but as soon as it hits some particles, the gas particles, water droplets, it deviates from its straight path. So the deviation of light from its straight path when it strikes tiny particles like dust, gas or water droplets in the atmosphere. On the other hand, Tyndall effect. What is Tyndall effect? When a beam of light strikes fine particles, here just particles. When beam of light strikes fine particles, right? Beam of light strikes fine particles, the path of those particles becomes visible. And that is, my friend, it is called Tyndall effect. And we are done with our session. We completed, okay. Before that, these are some of the questions that you need to remember. First, practice the human eye diagram. Then, why do stars twinkle but planets do not? That is because of atmospheric refraction, right? We have so many different layers of atmosphere, and in each the density of the ions, the particles is different. So the lights keep on diffracting, keep keeps on refracting, and since planets are very near to us, they do not, since stars are very far away from us, they appear as a point object, and from point object we understand that refraction is happening. But planets are very near to us and they are big in size, so rays from all the parts of that planet, it balances out, and we neglect the, and we do not see them twinkle, right? So this dance. Why is the color of the sky blue? Because blue scatters most and red does not. And the same for danger signals are red, because red does not deviate, does not scatters that much, right? Thank you, Akshara. That is it for today's live session. Like this session, very important, like this session. I will be giving the PDF in the WhatsApp group, so there is a link down in the description. Go join that WhatsApp channel and subscribe the channel, my friend. Okay? You have any doubt, let me know, or we'll close the live. Done, everyone? Oh, you are still here, Divyanshu? Okay. Very good, everyone. Keep studying, work hard. This is your final stretch. Only 10 days are left. And that is it for today's live. Like this session. Bye. Okay, bye.